Hi, today it is going to be a wrap-up of my whole lectures on a practical guide to quantitative finance interviews. So I'm going to walk through all the chapters in Green Book and trying to give you a general sense about what you can expect from each chapter and how should we leverage all the techniques and skills you learn from this book in your quantitative finance interviews. So first here is an overview about the Green Book. We can see the first chapter is about brain teaser, where we have 37 questions, and we are going to have calculus and linear algebra, which gives us 24. And the most important chapter here is the probability theory, where it contains 43 questions, which is the largest number within the whole book, where you can see about the importance of it. And next, we have the stochastic price and stochastic calculus. I think if you are undergraduate students, this probably be the weakest part, but it is going to be checked frequently for sales at quant for all those large investment bankings like Goldman Sachs, JP Morgan, all the way to UBS or Credit Suisse, which is gone. It contains 33 questions. It's going to be a good basic walkthrough for you if you haven't learned anything about that. And last but not least, we have finance, which is just a walkthrough about that. I think within about the importance, this one is definitely S level because it's used for both sell side and buy side. And the logic, all the methodologies it provides is going to be used frequently. And for brain teaser and calculus, it's more about the foundation. It's basically with A level. If you are from a mathematics related background, I think this is probably just a good material for you to do review or revision, but instead of picking up, from scratch. For this part, I will say A minus because you won't going to counter any of that for your buy-side interview, 99%. And for the last two chapters, this one, I would say you can neglect that because it's pretty old and outdated. And of course, coding is another important part for you to prepare your interview, but I would suggest prepare via lead code. One of the things I personally used is 代码随想录, which you can follow Carl for all the illustration. I think it's actually quite a good material and lessons. I'm going to retain here. And for finance, still, it's a little bit deviated from what is used nowadays. But still, for you to, it's still good for you to have a look at it and to know some basic knowledge. You haven't got any, so I'm going to call it B level importance here. So I think the most important thing is all these three parts, where this part you should go over review again and again. And if you say, okay, I'm already good enough, confident enough about the Green Book, which from my perspective means that once you have one question, you can directly link to one of the methodologies provided in this interview book. That's because you have a good understanding of that. Once you got that, you may go further to prepare your interview according to the specific companies. For example, if you receive an interview invitation from Goldman Sachs, then probably you should search for those real questions from historical interviewees to prepare for that. I would say most of the cases, they are all from Green Book if it's technical, or just slightly more difficult than it, but you can still solve it with basic methodologies. And I personally have gone through that for 3 times, but every time I go through it, I still get some new ideas and deepen my understanding of that. So I would say you can start from now and do it again and again. So here are some key methods I'm going to walk you through here. These 5, I think, are the most important. The first one is just simplification. You can see this actually applies to a lot of brain teasers and probability questions. So there are lots of times that the interviewer is going to throw you a question that you haven't seen before. And because you are nervous during the interview, you probably cannot come up with a perfect idea of that. But I would say at least 30% of the questions could be solved by math induction, which requires you to start from the simplest case, n equals to 1. And then we are going to infer that from n equals 2, 3, all the way to n and n plus 1. It's actually a good starting point, But of course, there are also a few questions that may violate this rule. But I would say anyway, when you go this back and forth with the interviewer, it is going to be a good way for you to start. And it's going to show them that you actually knows how to solve a difficult question by breaking them down into small pieces, starting from the simplest case. And the second thing is about think backwards. Backwards is actually an important idea, no matter in the whole quant field, no matter P quant or Q quant. For example, at the sell side, we have the binary tree, binomial tree pricing, which actually we think of the pricing of certain asset one step back and one step back. And for buy side, again, it's a case where sometimes the situation at t equals to t should be dependent on t minus 1, and also we're using leveraging the macro property. So with regarding to the problems, I think one classic problem is actually the 3 dice one, where you can toss your dice for 3 times and ask you how about what's the optimal policy. And it is actually one of the most classic ones. And third is the triennial discussion. You can see the brain teaser, the scale problem in brain teaser for that. It's actually a good way for you to understand when there is a complex question, you can break them down into 1, 2, or 3 scenarios, where each of them is quite simple to solve. I think it's a good way to show or elaborate that you have the ability to break down complex problems. Because when it comes to the real world trading or research, you may have a big project, but the thing you need to do at the very first day is to think about how to break them down into small research milestones, which could reach weekly or even at a daily level. And the first one is about symmetry and identical. There are a lot of, it's about when you get started for a probability question, no matter dice, coin, or cards, which are your 3 best friends when you're preparing your interview. You can't, sometimes a lot of times you need to think about what is replaceable, what is special, whether it is a symmetry or not. Why it is important? Because if you think about it, the sum of all the probability has to be 1. If any 2 events, E1 and E2 are symmetric, and their probability can be directly calculated as 1/2 without further argument. If you successfully solve a question in this way, it's going to show the interviewers that you have a nice numerical logic, but also a fast-paced intuition about the math problems, which is going to be good and could give you some bonus point. Last but not least is sometimes, especially for uniform distribution problem, which when you look into the certain chapters, I'm also going to talk in more details. Sometimes convert a schematic problem into geometry all the way back could be quite a good way to solve all the things. So for example, for the uniform distribution, for the Monte Carlo of simulation of pi, it's just about to form a unit circle within a square, right? And if we are talking about that, for example, like polar from the normal Euclidean intersections. So that's basically the 5 general key methods you should think about. And another thing is that when you interview, it is not just about solve this question correctly. You know, I personally have experienced some interviews where even though you solve it out, you may be rejected. But there are also ones that if you didn't come out with the correct answer, they still let you pass. And when I reflect on that, I think the key difference is that the discussion process with interviewers. First, you need to make sure he and you are always on the same, you and him are always on the same page, which means you should communicate frequently with him to check assumptions, which also earn you some time to think, right? And also starting from the initial simple cases to get deeper and deeper. By doing that, the interviewers are going to think you are going to be a good party to work with, which is quite important Because in reality, also there's not a lot of genius who could come out with the answer at the first glance, right? It's more about you can communicate well, be a good communicator, and have a quite solid logic reasoning to do things step by step. No matter, even though you can come out with the final answer, it is going to be much better than just be silent and working hard on a plan paper and then come up with the correct answer without walking through the process with the interviewers. So now let's come to the techniques regarding specific chapters. For brain teaser, it's one of the things is that we need to use the worst ones less and utilize the best ones even more than one times. For example, the river crossing problem. And the second thing is that we need to find conflicts, which means we're trying to prove something by showing that they kind of have a conflict and should not stand in both cases. And third is just one famous chapter, which is also our second video, out of box thinking. It's more about some, interesting brain teasers, more like 脑筋急转弯 you did when you were a childhood. Those things actually, I think, is the most difficult in an interview because you are going to be super nervous and have no mood for that. And this next one is that each term can be broken down into 2 and 5. It's just more about the factoring and the greatest division. It's actually a good lemma for you to remember. For the example question, you can see the trailing zeros. And the next one is just when you get stuck with current situation, thinking about if you can intentionally add one or move one element. For example, in the infinite sequences, we actually have a strange thing like 2, 2, 2, 2 equal to x. And the things we are thinking about is that whether we could use 2 added another x. So it remains to be equal to x. Or the other way around, x2 still equals to x. And then we solve it out, okay? And for the pigeonhole, you can just reference to the specific questions. It's just a very special type you need to focus on. And also, if you are coming from a mainland system, I think you will be familiar with series summation. If you are not, be better to revision about that. You need to have a good understanding of both an equals to an minus 1 plus something plus c, or an equal to like b multiplied by an minus 1, these two types, basic types. And also, if you are from a computer science background, this may not be the problem, but it's better for you to get familiar with modular and denotes. And if you got a strange number, for example, 9, 10, 11, you may standardize them into -1, 0, 1 for further discussion, which could probably simplify your process and makes it more efficient and elegant when you illustrate it to your interviewers. Last but not least, is just always do not forget there could be a way to prove by contradiction. And then for linear algebra, it's better for you to go overview the introduction chapters by yourself. It actually suggests more than what I listed here. For example, the hospital room, the Taylor expansion, approximation methods, Newton bisection second, actually being asked about this in real interviews, and also Lagrange multipliers. All these things are frequently being asked when interviewers want to check some basic understanding, when you want to check if you have some basic understanding of the mathematic technical skills, which could be more frequently asked even than some probability questions. Because they are simple, if you know that, you can just answer them in 1 second, but if not, it just makes you really awkward and ugly, and probably give you a rejection because of that. So trying to make yourself solid with all this foundation knowledge, because if you can't answer them, you are going to feel so guilty and like so regretted about that because they are not difficult. You just not have a good review of that. So really be careful about that. I'm going to stop here for like 30 seconds so that you can see all of these things. But again, they are all just screenshots from the green book. So take your time to review that. It's just about memorizing that instead of having some, high level understanding. And also be careful about ODE, all 4 types of ODE, because they are also frequently asked. And also the positive semi-definite and definite matrix. Why it is important? Because these 2 parts actually linked with the covariance matrix of normal of multi normal multivariate, distribution. And also related to SVD, EVD, SAS linked to PCA, and also OLS regression, which these two also has been tapping a little bit in Green Book. I suggest you to take some time to get a thorough overview of that. There are also two bodies that is going to be frequently asked, and it kind of linked the statistic with pure math. So I think it's about not only knowing the assumption of linear algebra, the assumption and the process to construct the PCA, but knowing exactly what the first component meaning and could have the ability to deal with some complex problems. For example, if we have y and x, and now y and x has been intentionally duplicated, what is going to be the changed data? What is going to be the change with the variance, the mean, and also like all the statistics? You need to know how to solve these questions from scratch because they are going to be checked a lot, especially by those top buy-side firms like Millennium, like Acura. Yeah, that's probably about that. And I also listed the assumptions here. Many people say that Green Book never talk about linear regression, but if you do look at that into details, you can find it at the linear algebra chapter, okay? But for this part, not only you need to know the assumption, you also need to know if one of them is violated, how should you deal with that? Or how should you detect or check whether some of them has been satisfied? Now let's come to the probability chapter. For probability chapter, some of them are quite basic. You need to know inclusion, exclusion. It's just about the inclusion, the trade-off between that, and could be useful to solve some questions related with some overlapping between these two. For example, A, B, and they have an overlapping part C. Really well, we can do things. It's just a inclusion B minus a intersection B, right? Which could be break down into A plus B, right? Minus this part. Binomial theorem, just trying to remember that it is linked with Poisson, linked with binomial. You also need to know like a binomial could be approximation to Poisson. And these two are also linked with Bernoulli and normal. You need to have a clear linked map within your mind, knowing that what's the relationship between them. Stars and bars, it's good to know, and sometimes it's quite useful for certain kind of combination and sequence questions. I wonder if you have seen the famous post on Xiaohongshu that, the 20 steps of a quant. Like the very two or third one is that 那道组合题毁了我的金牌梦. But anyway, so about that, it's just a joke. Maybe if you learn the star and bar well, you can solve that out. So do not let that combination question ruin your quant dream. Okay, have a good understanding of that. And then we also need to have like rational number. We need to like any rational number can be expressed as a fraction. It's something about the numerical series, good to know. Bayesians have a good understanding about this, quite foundational, and it's going to be checked by buy-side firms, and they are easy to learn and easy to solve. Situation recurrence, just referring to the coin toss game on page 80. And uniform and geometric solution, as I mentioned before. So like, it's related with this part, trying to link a uniform distribution with geometric methods. And for Poisson, it's also linked with exponential distribution. Please notice the memoryless property. It's linked with continuous Markov chain, which could lead to heating times, SDE, Black-Schoen. That's like another direction you could go with all these kind of continuous time distributions. And for moment generation function, trying to make sure you know the property. And you also need to know that ETX, this expectation may sometimes be a strange way to solve certain question. Okay, it is written here. And also expected value of max and min is in order statistics, 2.6 chapter, sorry, 4.6 chapter, I think. Just have a review of that, trying to memorize some important properties, like what's the distribution of the maximum of the uniform distribution and what's the minimums. Last but not least, the stochastic part. Well, there's nothing to say about that. Yeah, by the way, for this thing is just could be used to prove this one. To prove this one is the exponential martingale. As I mentioned, it's actually just a strange way to solve this question. The Green Book actually gives us the proof to that. You can check that. The stochastic part first, you need to know the equations for absorption probability and correlations, expected times is all the hitting time problems. You need to have your first step analysis. Okay, and then you are going to solve them based on the linked equations. And remember the reflection rule, just like the Breen teaser, and you need to know like a martingale stop at a stopping time, which could be noticed as large T, is also a martingale. No words equality, which is that ETX, if T is the starting time, is going to be ETEN. Okay, and then this one, together with this one are also martingale. This one is called bridge. And why this is important is because that it linked your current position with stopping time. For example, when they ask what's your expected stopping time, this one is frequently used. Okay. Last but not least, Ito's lemma. I think for this one, you may check some textbook because I think Green Book do not give you the real foundation or the derivation from scratch. They just give you the application. But I think you really need to have a good understanding on Ito's lemma. It takes a lot of time, like at least 1 or 2 days, but it's worth it. Okay, trying to make understand its linkage with Taylor expansion and how it is applied with Brownian calculus and the application, which is BS model. And all these things you should come up together frequently. I think you do not need to memorize every formula in stochastic because it's sometimes too complex. But for Ito's lemma, I still suggest you to memorize it, which makes you look professional. And I think it's not a too harsh requirement for students, right? So that's basically all of that. I hope you enjoy all my videos and I hope it helps. It has been a good journey with you guys. I started recording all these videos since July while trying to prepare and practice my oral English skills for this interviewing session, recruiting session. And I see like some of my videos may help some of you guys, and I really appreciate all your support. And I hope it could help others. So I make this web app. And good luck with your future career endeavor. And it does not come from a rejection letter. I hope it comes from an offer. So thank you for your time watching that. Bye-bye.